2025 A-Level Combined Mathematics Paper 1 Part A Question 2. This question is about graphs and it's about the modulus function. So this question says, sketch the graphs of y equals modulus of x minus 2 plus 2 and y equals 7 minus modulus of x plus 3 in the same diagram, and hence solve the equation x minus 2 modulus plus x plus 3 modulus equals 5. Now first off, to sketch these two we can use a couple of shortcuts. We know that for a modulus function, the only interesting thing that happens when the internal part of the modulus becomes 0. Because when that happens, to the right side of that point, there's one behavior for the modulus function, and to the left side, there's a different behavior. So here, if we look at the first function, we can see there's a modulus of x minus 2, meaning that something special happens when x minus 2 is equal to 0, which means that something special happens when x is equal to 2. Similarly, for the second one, we can see we have y equals 7 minus modulus of x plus 3, meaning that something special happens when x plus 3 is equal to 0, i.e. x is equal to minus 3. So there are 2 points at which something special happens, and the 2 points at which something special happens are x equals 2, which is this point, and x equals minus 3, which is this point here. So at these 2 points, something special is going to happen with the graphs. They are going to change shape and do something different. Now, using that, if we consider what they're going to do, we can start to identify the shape of the graphs by identifying certain specific points that these two graphs pass through. For the first graph, let's try substituting x equals 0. Substituting x equals 0, we get 0 minus 2, which is minus 2, and modulus, which is plus 2, which is 4. So therefore, for the first graph, when x is equal to 0, y is equal to 4. So this is one of the points on this graph. If we consider the special point when the internal bit is 0, as in x equals 2, we have 2 minus 2, which is 0, modulus of 0 is 0 plus 2, which means that when x is equal to 2, for the first graph, we get y equal to 2 as well. So this right here is another point on this line. Furthermore, if we try another one, let's say x equals 4. For x equals 4, we get 4 minus 2, which is going to be plus 2. Modulus of plus 2 is plus 2, and plus another 2, that gives us 4, which means that for x equals 4, the line here again passes through y equals 4. So therefore, we have these 3 points to work on. Now, since we know that for anything past x equals 2, the behavior of the first graph is going to be linear, as in nothing changes, we can just draw a straight line through these 2 points and declare that this is all that this graph is going to do after this point. Similarly, for all the values less than x equals 2, we can say that the graph is not going to change shape beyond that point, and therefore the shape of that graph beyond that point is going to look like this. Now that we've done that, we can do an additional step which is not really necessary but will help you. We can draw the equation of this graph and this graph. So for this graph is the graph that happens when x is greater than 2. When x is greater than 2, if we look at the actual equation of that thing, we can see for the modulus part, x greater than 2 means x minus 2 is greater than 0, which means that this internal value is positive, meaning that if you take the modulus, you're going to get the same value as the internal value. Meaning that the modulus of x minus 2 is the same as x minus 2 for x is greater than 2. Which means that this graph simplifies to y equals x minus 2 plus 2, which simplifies to y equals x. So therefore, this graph here is y equals x. Similarly, if you do the same thing for the stuff on the left side, x minus 2 is negative since x is less than 2, meaning if you take the modulus of x minus 2, it's going to be 2 minus x, since the modulus always gives you the positive value. So then we have y equals 2 minus x plus 2, and y equals 2 minus x plus 2 means that this graph here is going to be y equals 4 minus x. So now that we have that, we know the graphs of both of these individual components separately. We do not really need to do that, but when we do it, we could potentially find it easier to solve the actual problem. Now, let's do the same exact thing for this graph here. We know that at x equals 3, something special minus 3, something special happens. At x equals minus 3, this part becomes 0. So we have 7 minus 0, which is 7, which means that at x equals 3 minus 3, we're going to have y equals 7, which we can see the graph lines up and we do get y equals 7 here. Now, if we consider what happens to the left hand side and right hand side. On the right hand side, the x is going to be greater than negative 3, which means that x plus 3 is going to be greater than 0, which means that when you do the absolute value of x plus 3, nothing's going to change, it's still going to be x plus 3. So then if you consider the graph, it's going to be y equals 7 minus x minus 3, which is going to be 7 minus 3 minus x, which is going to be 4 minus x, which means that the graph of this function to the right side is going to be y equals 4 minus x, which is the exact same as the left hand side part of the other graph. So for this thing, this graph here is also going to be y equals 4 minus x. Now on the left side of minus 3, as in this side, if we consider x as less than minus 3, this bit on the inside here is going to be negative, meaning that when we take the modulus is going to be positive, which means that we need to swap this thing the other side around, which means now we have negative x minus 3 on the inside. So when we subtract that from 7, we get 7 plus x plus 3, which is 10 plus x, meaning that the graph of that half is going to be 10 plus x. So if we draw that part of the graph, that part of the graph is going to be y equals 10 plus x. Now, if we consider what we're actually expected to solve based on this equation here, we're expected to solve based on the graph, this equation which says that the modulus of x minus 2 plus the modulus of x plus 3 is equal to 5. If we write this down and rearrange it, we can see that first off, if we write modulus of x minus 2 plus modulus of x plus 3, we can see that this modulus bit is there in our first graph's modulus part. We can also see that the second modulus bit is there in the second graph's modulus part. And we can see if we take this equal to 5 and we rearrange it a little bit, we get that the modulus of x minus 2 plus 2 must be equal to 7 minus the modulus of x plus 3. We can get this by adding 2 to both sides and then subtracting the modulus of x plus 3 from both sides. So we can see that this statement is exactly the same as this statement. Now, if you look at this statement, you can see the left hand side is exactly what we get from this first graph, and the right hand side is exactly what we get from the second graph. Now, what does this mean? This means that in order to satisfy this equation, this graph and this graph must intersect, because the two y values being equal is what results in absolute value of x minus 2 plus 2 being equal to 7 minus the absolute value of x plus 3. So therefore, the two graphs should intersect in order for this to be true. Where do the two graphs intersect? Well, the two graphs intersect from this point here, where the first graph and the second graph are both y equals 4 minus x, until this point here, where the two graphs stop being y equals 4 minus x and y equals 4 minus x. Therefore, this entire range of values from from x equals minus 3 all the way up to x equals 2 are the values of x for which the two graphs intersect. So we can see down here from the graph, this happens for the values of x which are an element of the set starting from and including the value of x which is minus 3. So including the value of x which is minus 3, which is why you put the square bracket here, all the way up to the final value of x, where that which this stops happening, which is when this graph goes up and this graph goes down, which occurs at x equals 2. So the final value here is x equals 2, and x equals 2 as well is included, so we have to include x equals 2. Meaning that these two ranges are the ranges for which this equation holds, and therefore we can say not these two ranges, these two limits are the limits for which this equation holds, meaning that the range of x for which this works is this range here. We could of course also write this as like something like this. We could write it as being also the values of x where x is anything greater than or equal to 3 minus 3, anything less than or equal to 2. But I prefer this notation compared to this notation, but if you write this way, you are not wrong. This is also absolutely correct. So there we go, that is the solution. And for this kind of question where you spend most of your time drawing the graph and marking out each of the individual graphs, you do not need to provide that much explanation for the last bit, which is why I have only written that this thing is this thing, and from the graph we can say that x is an element of this set. So in this kind of question, you can kind of get a tip that you don't really need to write much for the actual logic when you actually draw the graph. You can see this from the mark schemes, where in the mark schemes as well, they don't include that much of the logic at the end because the graph encompasses most of the logic. You could do something like, mark this particular range of x and show something like this with a curly bracket like this to indicate that you know that this is the values of x that's important, but in the end, for the actual logic, you don't need that much. Finally, if we consider the marks involved here, for the first graph's first part, the y equals x minus 2 absolute value plus 2 graph's first part, on the right hand side, as in the y equals x bit, starting from x equals 2 and going upward, you get 5 marks. For the other part of this graph, y equals modulus of x minus 2 plus 2, that goes to the left of x equals 2, you get another 5 marks. So for this part, you get another 5 marks. Similarly, For the two parts of y equals 7 minus modulus of x plus 3, this part which is y equals 10 plus x, you get 5 marks, and for this part which is y equals 4 minus x, you get another 5 marks. So you get 5 marks, 5 marks, 5 marks, 5 marks, in total 20 marks for the entire graph. And finally, the last remaining 5 marks goes to this final solution here. So you can see a majority of the marks for this question are going into actually drawing the graph, and for that reason you can justify again not writing that much for the final logic. For this final bit you don't need to write that much because most of the marks anyway are going into actually drawing the graph. So that's all for this question. I hope you enjoyed. If you have any comments or anything like that, any feedback, post them in the comments down below. Thank you for watching and goodbye.